I'm Ken Liu. I'm the professor and the chair of the Department of Oceanography and Coastal Sciences. Um, well, I can say that most, if not all, of what I do these days can be summarized by these two terms: paleotempestology and coastal paleoecology. And just to clarify what these two terms mean, paleotempestology is a young field of science that uses geological proxy techniques to reconstruct a long-term record of hurricane activities. And coastal paleoecology is a field that uses primarily microfossil data. And in my case, I use fossil pollen in the field of palynology in sedimentary records to reconstruct the history of coastal environmental changes. Now, I've done this kind of work for decades and in many places, including the Gulf Coast, the Atlantic Coast, the Caribbean, Central America, Mexico, and in other parts of the world as well. But today I will try to show you an example from the Rockefeller Wildlife Refuge in southwestern Louisiana. Now, you may know that until last year, 2020, when Louisiana was hit by 5 hurricanes, including Hurricane Laura. But before 2020, this part of Louisiana had been hit by 2 major hurricanes: Hurricane Rita of 2005 and Hurricane Ike of 2008. This part of Louisiana had been hit by these 2 storms with very high storm surges. And we collected several sediment slabs from the salt marsh behind the beach barrier to study the sedimentary impacts of these 2 storms. And we found 2 sand layers here in each core. Near the top of the core, and these 2 storm deposits were characterized by low organic matter. These are the loss oxidation curves. Low organic matter, high carbonates, and high concentrations of marine chemical elements like calcium and strontium, and also high ratios of calcium to titanium and chlorine to bromine. These are marine indicators. So they indicate that there was a storm surge and overwash process that brought seawater into our study sites. Now, so that is the paleotempestology part, but we also took a 5.25 meter long core, and we did pollen analysis on this core. And we can see, we can group the different pollen types into 5 groups. They represent marine forest, swamp, marsh, and beach environments. Now, so we can see that there are significant changes in the ratios or proportions of different groups. And by means of principal component analysis, we can interpret the pollen data into the stratigraphic changes. And we can see that in the last 5,200 years, the environment, the coastal environment has changed from a swamp to a maritime forest, back to a swamp, and then to a marsh and to a beach. Now we can translate this stratigraphic changes into a 2-dimensional coastal profile. And we can see that from 5,200 to 4,200 years ago, our study site, the coring site, was surrounded by a swamp. And then in the next 1,000 years, from 4,200 to about 3,400 years ago, the swamp environment has changed to a maritime forest. And then from 3,400 to 1,500 years ago, the environment has changed from a forest back to a swamp again. Now, since, along the coastal environment, we have a transect from forest to swamp to marsh and dune. We can interpret this as relative sea level changes or in terms of shoreline fluctuations during the last several thousand years. And in the next 1,200 years, from 1,500 to 300 years ago, the coring environment changed from a swamp to a marsh, meaning that the coastline has retreated In other words, the sea has advanced getting closer to the site. And then in the last 300 years, it was changed to a dune or beach community environment. So we interpreted the fluctuations in this coastline changes in terms of the delta switch of the Mississippi River Delta. When the Mississippi River Delta was switched to the west, we have shoreline advance. But when the Mississippi River Delta switched to the east, the shoreline retreated because there is a reduction of sediment supply.